Good morning students. What was learned in the previous class ma? In the previous class we was discussed some numerical problems in unit 3. Okay. In the today's session I will start the fourth lesson. Okay. The fourth lesson topic is electromagnetic induction and alternating current. It's a very interesting lesson. Okay. Electromagnetic induction and alternating current. In the second lesson we had discussed what is current, what is electricity, what is current density and what is resistance, what are the how to resistor to be connected in series and parallel, that all are discussed in the second lesson. Completely will be based on the current. In the third lesson, how current to be create the magnetic field. The current will be falling on a conductor, the surrounding surface some magnetic field to be created. That's a concept we had discussed in the third topic. So, in the today's session, I will explain the converse effect of the third lesson concept. What is third lesson concept? Current it will be falling on any one conductor, the magnetic field to be created. So, that the concept is the current to be created the magnetic field. So, that the converse effect, what is the meaning that converse effect? Magnetic field to be create the current. In the third lesson, current to be create the magnetic field. Okay. Current will be passed on to the any one conductor, the magnetic field to be created to the surrounding the conductor. That the concept in third lesson. But this lesson concept is the converse effect of this third lesson concept. What is this? Magnetic field to be create the current. Okay. So that is called electromagnetic inductions. Electromagnets induced some current. That's a concept for fourth lesson. Okay. So first I explain what is electromagnetic induction. Electromagnetic induction, what is called electromagnetic induction? The heading tells the answer. Electromagnets are magnets in any one place to be create the current, to be induce the current. That will be called as electromagnetic induction. Induce of current by using any bore magnets or any magnetic field or anything. Okay. So electromagnetic induction is nothing but magnet to be create the current. That's all. Okay. So electromagnetic induction defined as the current to be induced by magnets. Okay. That is called electromagnetic induction. First you have to think of it, the electromagnetic induction. One scientist will come say in front of our face, that is Michael Faraday. Michael Faraday is the father of electromagnetic induction. Okay. The scientist Michael Faraday give their theory or give their speech in one conference. Okay. So in one conference he had given the one lecture on the basis of electromagnetic induction. Okay. So he completely will be give the speech on this lecture part. One person, one member in the audience, okay, one member in the audience approached to him and asked to him, one person in the audience or one member in the audience in the lecture hall approaches Michael Faraday to ask to him, you explain the flux linkage in the coil and then magnet and the moving magnet to be create the current, to induce the current. Okay, that's a concept. Explanation is very interesting, but what is the use of it? That's the man to be asked to the Faraday. But Faraday, Michael Faraday, will be answered to him very quietly and with a sweet smile or with great smile. He tells that what is the use of a newborn baby? What is the use of newborn baby? So we will see the greatness of that little child who has how grown as an adult to the cater to the energy needs. Okay. So nothing for a new concept, nothing is interesting for the new concept. Then the new concept it will be applicable to in various fields. It will be grown up the field, the concept it will be applicable. It will be applied to some phenomenon and that phenomenon it will be used to the daily life. So that is the great exposure to give the, that's the great advantages to the electromagnetic induction. Okay. So Michael Faraday will be give the lecture and submit the lecture on electromagnetic induction. Okay. Electromagnetic induction father, Michael Faraday is the father of electromagnetic induction. Clear ma? So in this lesson we had discussed, we will be discussed electromagnetic induction and then Faraday's experiment and Faraday's laws also. Okay. So first, what is called electromagnetic induction? Already I told. Electromagnetic induction means current is induced by magnetic field. Magnetic field, it will be induce the current, or magnetic field to be create the current. Okay. Michael Faraday did the experiment, various experiments to explain the electromagnetic induction. Okay. He take the coil and the magnet will be moving through or away from the coil. Flux changes to be created in the coil, and the coil to be induce the current. That's the concept for Michael Faraday. Okay. Michael Faraday applies a magnetic field, that the magnetic field, it will be create the current or induce the current in the coil. That is the concept for Michael Faraday. That's the concept is known as induced current. That the concept it will be known as electromagnetic induction. So before enter the Faraday's experiment, first we want to know that what is magnetic flux. Already learned in first standard what is electric flux. Electric flux is nothing but electric field lines is crossed at a particular area, crossed per given area. That's the same concept as magnetic flux means magnetic flux, that's a magnetic lines of force. It will be travel in a given area. It will be travel in a particular area. So magnetic lines of force crossing a given area, it will be called as magnetic flux. Clear? So what is the symbol for flux ma? Flux pi B is equal to close integral of B dot dA. Okay. B is the magnetic field, dA is a crossing area. Okay. So we have to consider one circular coil. Okay. The magnetic field will be falling perpendicular to the plane of the paper or plane of the coil. Okay. Clear? So how many lines it will be crossing at a particular area of the coil? That it will be mentioned as a term of magnetic flux. So magnetic flux symbol is by pi B. So the closed integral of B dot dA. Okay. So closed integral means we have to consider one closed circuit. Closed circuit means a circuit will be start from one point and then end at the same point. That is the closed circuit. So we have to consider one closed circuit. We have to mention the magnetic field and the area. So B dot dA. So B dA cos theta. B dA, how B dA cos theta you have to put? A dot B is equal to A vector dot B vector is equal to AB cos theta. So B dot dA is equal to B vector, sorry, not a vector, B dA cos theta. Clear ma? So we have to take the B cos theta at the outside. B dA cos theta, close integral of B dot dA cos theta, not a dot ma, B dA cos theta, and we have to calculate the integral for dA. B cos theta will be taken as outside. So B cos theta, close integral of dA. So B cos theta, close integral of dA, common A, integral of dx is equal to x. So integral of dA is equal to A. So flux, magnetic flux by P is equal to B dot A, not a dot, B into A or anything, B into A. That's the magnetic flux, magnetic flux is the equal to product of magnetic field strength and area. Okay. So what is the unit of magnetic flux ma? The unit of magnetic flux is Weber, or the unit of magnetic field is Tesla, unit of area is meter square. So area of the magnetic flux is equal to Tesla meter square. Tesla meter square. Okay. What does it mean by magnetic flux ma? Magnetic flux is nothing but magnetic field lines is crossed at a particular area or crossed per given area. Okay. Crossed a particular area, what's the meaning that magnetic flux is equal to close integral of B vector dot dA. So B dot dA is equal to B dA cos theta. So B dA, integral of dA, it will be mentioned as A. So B A cos theta. Okay. So B A cos theta, where the cos theta it will be going? Theta we have to consider as 90 degrees. So cos 90 value is, because the magnetic field it will be perpendicular to the plane of the coil. So the theta angle should be taken as cos 90. So cos 90 value is 0. Sometimes the magnetic field will be considered as along the coil. So theta value will be considered as 0. So theta to be taken as 0, cos 0, 1. Okay, cos 0 value is 1. So the coil it will be parallel to the magnetic field. So parallel to the magnetic field, the angle is theta. So cos 0, 1. So we easily calculate it B into A. cos 0 1. So we have to multiply by 1, easily get the formula for magnetic flux is equal to B dot A. So that will be called as magnetic flux. Now we will go for Faraday's experiments. Faraday did the various experiments to explain the electromagnetic induction. Okay, first I explain the Faraday's first experiment. Faraday took one coil. Okay, coil means it's like a solenoid. The coil, it will be wound various number of turns to make just like a spring. Okay, so this will act as a solenoid. Okay, take one coil, that the coil having number of turns. The coil, it will be connected to the two terminal of the two ends of the coil to be connected to the galvanometer 2 points. Okay, galvanometer having the two upper points, that the upper points to be connected to the two ends of the coil. Clear? This is the first setup. So this is the coil. The two ends of the coil to be connected to the galvanometer 2 terminals. Clear ma? Then take one bar magnet. The bar magnet is having two poles. One is north pole, another one is south pole. So the north pole of the bar magnet, brought near to the coil, is bring near to the coil, that the coil having some current to be induced, that the way the galvanometer to be deflected. So first experiment is a bar magnet, it will be moving towards to the coil, galvanometer shows deflection. Okay, and then bar magnet, it will be removed from the coil, it will be moved away from the coil, galvanometer shows deflection. Okay, suppose the bar magnet, it will be keep as a rest position in the inside of the solenoid or inside of the coil. The magnet to be rest in the inside of the coil or solenoid. That the time galvanometer shows null deflection. Galvanometer shows does not show any deflection. The galvanometer always shows the null deflection. What the meaning that the magnet, it will be moving near to the coil or is move away from the coil, only deflection to be produced. Not to be in a rest position, not the only movable magnet to be create the induced current, not in a rest magnet. Okay, this is the first experiment. Okay, next I will tell the second experiment. After I have to explain the conclusion point of first and second experiment. Okay, so what is the second experiment? Second experiment is take one coil. Again you have to connect the two terminals of the coil with the two terminals of the galvanometer. Okay, and this is the primary circuit. You have to consider this is the primary circuit. Next we have to connect again one coil. Okay, that the coil, it will be connected with a battery and key. Okay, that the two coils touching with each other, does not with each other. Okay, so first we have to take one coil, that the coil, it will be connected to the battery and key coil, and the coil to be connected with battery and key. Clear? Okay, that the two coils do not touch with each other. The key to be open, what's the meaning that open? The key to be open, does not closed. The key to be open, no current will be falling, so no current change is there. Okay, the key does it will be open. The key to be open, what's the meaning that open? Open means the two terminals does not to be in contact, so no current will be falling. So the current does not to be falling, the coil does not to be having any current. Okay, so there is no deflection in the galvanometer, but we have to close the switch. We have to close the switch. The current will be falling from the battery. The current will be falling on the coil to be increased. That the way the current, it will be induce a current for the next second coil, secondary circuit coil. That the way the galvanometer shows deflection. That the way the galvanometer shows deflection. No magnet to be used in this experiment. Only the coil act as a magnet, because it will be the coil, it will be falling the current, getting the current from the battery. Okay, so that the coil will be act as a magnet, that the magnet will be induced current to the secondary circuit coil, That the way only the galvanometer shows the deflection. Clear? Suppose we have to supply the opposite current, otherwise the current it will be falling on the coil to be increased. One time the current it will be reach the steady flow, that the steady flow galvanometer automatically shows the null deflection. The steady flow means the current flowing direction does not to be changed. The current flowing value does not change. That the time is a constant current flow in the first coil. So the constant current flow in the first coil, galvanometer shows the null deflection, no deflection at all. Okay. Suppose we have to open the switch, the current it will be reduced, current it will be decreases in the coil, that the time also galvanometer shows the deflection. First this deflection is left side, next the deflection is the right side. Okay. So now in this process also the galvanometer shows the deflection, because the current it will be decreasing, not to be in a steady current. Okay. This process will be going the current as so long as the current in the coil. Okay. This is the Faraday's second experiment. So what is the conclusion for the Faraday's first experiment and second experiment? What's the concept of first experiment? What's the concept of second experiment? What I have seen in the first experiment, having in a coil, okay, having in a galvanometer, the bar magnet, north pole of the bar magnet, it will be moving towards the coil. The magnetic flux lines it will be passing on the coil to be increases. Magnetic field from the magnet, the flux linkage in the coil to be increased. So that the way they induce some current in the coil. Okay, induce some current in the coil, that the way only the galvanometer shows the left side deflection. The galvanometer shows the left side deflection. Okay, now we have to remove the magnet from the coil. We have to we have to brought the magnet away from the coil. That the time also magnetic flux lines it will be linked with the coil to be decreases. That the way also the galvanometer shows the deflection at the right side. Okay, at the right side. But you have to keep the magnet inside of the solenoid or inside the coil as at rest. No magnetic flux changes at all. So no magnetic flux changes, no to be the current to be induced, because magnetic flux changes only create the current or only induce the current. Okay, that is the Faraday's first experiment. That's the concept of first law. Okay, what is Faraday's first law? The magnet it will be moving near or away from the coil, current to be induced. So whenever the magnetic flux it will be linked with the coil to be changes, the current to be induced, that the current it will be called as induced current. One EMF it will be developed in the circuit, that the EMF it will be called as induced EMF. So the first law it will be state that induced EMF, induced current, and then it will be give the concept of electromagnetic induction. That the phenomenon it will be called as electromagnetic induction. Again I told the Faraday's first law. What is Faraday's first law? Whenever the magnetic flux it will be linked with the coil changes, that the time definitely the EMF it will be induced in the circuit, and one current it will be induced in the circuit. That the induced EMF it will be called as induced EMF, and that the current to be called as induced current. That the phenomenon it will be called as electromagnetic induction. Okay, that it will be called as the Faraday's first law. So this process will be going as a long lasting as long as the magnetic flux it will be linked with the coil to be changes. எவ்வளோ நேரம் அந்த link magnetic field link ஆகிட்டே இருக்குதோ அது வரைக்கும் இந்த process it will be goes on, it will be going. Okay, so again I will tell the Faraday's first law. He did one experiment, take one coil, the bar magnet it will be keep near to the coil or is brought near to the coil, north pole of the magnet to be moving towards to the coil. Suppose you have to do the activity, you have to brought near one south pole of the magnet also. That the time galvanometer shows the opposite deflection. Okay, it will be clear that you have to bring north pole or south pole, any one of the magnet to be brought near to the coil. The magnetic flux lines it will be linked with the coil to be changes. The magnetic field it will be comes from the magnet, that the magnetic lines will be fall on to the coil. The coil is having magnetic flux link changes. That the magnetic flux changes, it will be create one EMF. That the EMF it will be called as induced EMF. That the current it will be called as induced current. That the phenomenon it will be called as electromagnetic induction. That is the Faraday's first law. Next we will go for Faraday's second law. Faraday will be choose the two circuits. One is primary and one is secondary. In the primary circuit one coil is there, and secondary circuit also one coil is there. The first circuit is having one coil and battery and key. Okay, and second circuit having one coil and galvanometer. Clear? No magnet at all. Okay, no magnet to be chosen. So one coil it will be connected with the battery. Switch is there. The switch to be open, no current will be falling on the coil by the battery. Okay, no current will be flowing, no deflection in the galvanometer. Now we have to close the key. The battery will be giving the current to the coil. The coil it will be the current in the coil it will be increased. The magnetic flux line it will be linked with the another one coil. Magnetic flux links. The current it will be falling to be increased in the coil. Automatically magnetic field it will be created in the middle part of the coil. That it will be create the magnetic field. The magnetic field it will be linked with the near coil. It will be changed because the current it will be increased. The magnetic flux lines will be increased and continuously changes with the second coil. So the second coil it will be definitely be create the current. That the current it will be completely shows the deflection in a galvanometer. Suppose we have to again you have to close the switch. The current it will be decreases. Often the current to be decreases. The magnetic flux linked with the coil to be also decreases. The galvanometer shows opposite deflection. The galvanometer shows the opposite deflection. And suppose the current it will be the switch to be on. The current to be increasing. One time the current it will be reach the steady flow. That the steady flow, no deflection in the galvanometer because no flux changes at all. So current it will be increase or decrease, only magnetic flux changes it will be created. That the magnetic flux changes it will be linked with the coil, only current to be induced. Clear? So the first primary circuit it will be act as a magnet. Okay, because the current flowing in the coil it will be create some magnetic field. So the magnet it will be act as a bar magnet. Sometimes north and south pole we have to choose. So we have to change the direction of the coil also. We have to change the magnetic flux lines. It will be linked with the secondary circuit also. We have to change. That the time the galvanometer shows the opposite deflection. This is the Faraday's second law. So Faraday's second law states that the magnetic flux psi is equal to magnetic flux or induced EMF. Induced EMF is equal to d pi by dt. Flux changes at a particular time. So second law will be state that magnitude of induced EMF is equal to the time rate of magnetic flux changes with a coil. The magnetic flux linked with a coil it will be changes at a particular time. That the ratio it will be equal to the induced EMF. Okay. So induced EMF it will be equal to the time rate of change of magnetic flux is linked with the coil. Okay, so d pi by dt. Suppose the coil is having number of turns capital N, so that the way only n into d pi by dt. N is the number of turns in the coil. Okay, so n into d pi by dt. So d pi by dt is the we have to remove the differentiation. D pi by dt it will be equal to pi. So n into pi b. By p means in the magnetic flux it will be mentioned. So this will be called as n into by p it will be called as flux linkage. So what is called flux linkage? Flux linkage it will be equal to the product of number of turns and magnetic flux. Okay, number of turns and magnetic flux. So that will be called as flux linkage. Flux linkage is equal to the product of number of turns and magnetic flux. So this is the Faraday's first law and second law. Again I tell the Faraday's first law and second law. Faraday's first law, whenever the magnetic flux is linked with a coil it will be changes. that the time one EMF is induced in the circuit, that the EMF it will be called as induced EMF. That the time the current to be induced in the circuit, that the current it will be called as induced current. That the phenomenon it will be called as electromagnetic induction. That the process it will be long lasting whenever so as long as the electromagnetic induction process is done in this phenomenon. Okay, the magnetic flux will be linked with the coil, it will be changes, that the time only that the process will be going. Okay, then what is the Faraday's second law? Faraday's second law means one current it will be induced, that the induced EMF or induced current, the strength of induced EMF is equal to the rate of change of time due to the flux changes is linked with the coil. Time rate change of magnetic flux will be linked with the coil to be changes. Okay, so psi is equal to N into pi P. N into pi P will be called as flux linkage. Flux linkage is equal to the product of number of turns and magnetic flux it will be linked with the coil. Okay, clear that? This is the Faraday's first law and second law. So what is the use of electromagnetic induction? Faraday did the experiment, he proved that he gave the concept of electromagnetic induction. What's the use of it? Okay, so in our daily life we use more and more electronic appliances. Begin from the home appliances too. In our home having TV, fridge, washing machine and mixie, grinder and more electronic appliances there, iron box, AC, inverter. So more and more electronic appliances there. All the electronic appliances need electricity. Home appliance in our home to factory machineries and computer to internet and then toys, electric toys, all are need electricity. In the 20th era does not live without the electricity. Okay, so electricity is a very predominant factor to sustain our life in the today generations or today era. Okay, in this era we need the electricity to carry out our life. Okay, but electricity is very demand. Okay, so electromagnetic induction is rectify the demand for electric power, because electric generators and transformer it will be transmit the electricity from one place to another place easily, and then generators when the power to be off, the generator will be used to supply the power supply to our home. So generators and transformers is very much useful for in our day-to-day life. So generators and transformer completely works on the base of electromagnetic induction. So without the electromagnetic inductions, we does not sustain our life. We does not carry out our life in this era. Okay. So electromagnetic induction is very much useful in our day-to-day life. Okay. So then, what is the activity for electromagnetic induction? I will give one activity. Already I explained that activity. Faraday's experiment. Already I explained the Faraday's first experiment. That is the activity for this concept. We have to take one circular shape, cylindrical shape, one coil or one rod, one tube. Okay, one metal tube you have to choose that the tube size is cylindrical shape. Okay, we have to take the copper wire. The copper wire is wound on the. We take one tube, metal tube. That the tube it will be made up of aluminum, and then we take on the copper. The copper it will be turns over on completely. It will be turns over on the cylindrical shape metal tube. Okay, that the two terminals of the wire to be connected to the galvanometer or anything, galvanometer, the two terminals of the wire to be connected to the two ends of the galvanometer. Okay, and then we have to take one magnet. The magnet, south pole of the magnet, south pole side or north pole side, you have to take the magnet and then you have to bring near to the one side of the coil. Okay, that the time the galvanometer definitely shows the deflection in the right side. Okay, suppose you have to move away the magnet from the coil, the galvanometer shows the opposite deflection. Suppose you have to keep the magnets inside of the coil, no deflection at all. So this is the one activity to explain the electromagnetic induction, to explain the Faraday's first law. Okay, you have to did this activity. We take the bar magnet and one metal tube, and then one copper wire or any one wire or metal wire. The metal wire, it will be wound over on the helical shape, say it will be wound over on the metal tube. The metal wire to be connected to the two terminals with the galvanometer. We have to bring one side of the magnet to near to the one side of the coil. Definitely that the time the galvanometer shows the deflection in the right side, and then you have to remove the magnet from the, withdrawn the magnet from the coil. At that time only galvanometer shows the opposite deflection. So this is the one activity for electromagnetic induction. Okay. So in the today's session I explain first what is the definition of electromagnetic induction. What is the definition of electromagnetic induction? Electromagnetic induction is nothing but the magnetic flux changes to be create the current. That is electromagnetic induction. Current to be induced by using electromagnets or magnetic field. That is will be called as electromagnetic induction. Second one is magnetic flux. What is the meaning that magnetic flux? Magnetic flux is nothing but magnetic lines crossing per given area, crossing at a particular area, crossing at a particular area. Okay, so that is the formula for that. Magnetic flux pi B is equal to close integral of B dot dA. So what is the meaning that B dot dA? B vector dot dA vector. Magnetic fields, it will be crossing at a particular area. So B vector dot dA vector. A dot B, AB cos theta. So close integral of B dA cos theta. In this part, theta to be considered as 0 because the magnetic field lines will be parallel to the plane of the coil. So it will be parallel to the plane of the coil. The theta angle to be considered 0. Cos 0 value is 1. So close integral of B dot D not a dot B dA. Okay. So we taking B as a common as close integral of dA. Integral of dA A. So BA. This is the magnetic flux formula B into A. Okay. What's the unit of magnetic flux? That is a Weber, and another one in unit ampere, sorry not ampere, decimeter square, decimeter square. Because the magnetic induction or magnetic field strength, that is Tesla, and area meter square. So decimeter square. This is the unit for magnetic flux. Clear? And then Faraday's first experiment, second experiment. Faraday's first experiment, if Faraday, it will be take the two experiments. To take the one coil and the bar magnet and galvanometer. Then take one coil, he took one coil, that the coil two ends to be connected to terminals of the galvanometer, and then he brought a magnet near from the one side of the coil. The galvanometer shows one side deflection, and he moved away the magnet from the coil. Galvanometer shows the opposite deflection. Suppose the magnet, it will be located in rest in the inside of the solenoid, inside of the coil. The galvanometer shows null deflection. This is the first experiment. Okay, when the deflection it will be produced in the coil, deflection it will be produced in the galvanometer by the changes of movement of movement of the magnet. That is the Faraday's first experiment. And second experiment means he took one coil with connected with battery and key, and took another one coil, that the coil it will be connected with galvanometer. The first coil, the current it will be falling, the current to be increases in the first coil, automatically they induce the current in the second coil. That the way only the galvanometer shows the deflection. Okay, that the two experiments will be given. Electromagnetic induction or magnetic flux lines, it will be linked with the coil to be changes. That the time only the current to be induced. That the current it will be called as induced current. That the phenomenon it will be called as electromagnetic induction. That the process it will be goes on so long as the magnetic flux it will be changes with the coil. Okay. So and the Faraday's second experiment is induced EMF, it will be equal to the time rate of flux, it will be linked with the coil. So N into d pi by dt. d pi by dt means rate of change of flux as linked with the coil. So N into d pi by dt, so N into pi. So d pi by dt it will be taken as pi. So that is the flux linkage. Flux linkage, it will be equal to the product of number of turns and flux, it will be linked with the coil. Clear? So that is the Faraday's second law. Okay. And then Faraday's first law, it will be give the activity for you. So Faraday's first law is you take one cylindrical shaped metal rod, and then we have to take one metal wire, that is just like a copper. The copper, it will be wound over on a cylindrical tube, and the two ends of the coil to be connected to the galvanometer. We brought one magnet, it will be near to the one side of the coil. The magnetic flux will be linked with the coil to be changes, and on the time the galvanometer shows the deflection. Okay, clear? So this is the activity for you, it will be given in our book. Okay, and then what's the use of electromagnetic induction? In the day-to-day life, we use more and more electronic appliances. That the time demand, it will becomes the demand for electric power. So electromagnetic induction will be rectify the demand for electrical power. How? We use the electric generators and transformer to transfer the electricity to the various places at very long distances, and then electric generator will be gives the electricity for when the power to be off in our home or any places. Okay, so the electric generators and transformer, it will be completely works on the basis of electromagnetic induction. And then one interesting concept also I had given, that is Faraday, it will be give the lecture on any one conference, given in any one conference, that a member in the conference, one member in the audience, he approaches to Faraday. He did ask one question, that the question is your concept, that is a coil and flux changes and then electromagnetic induction is very quite interesting, but what was the use of it? What is the use of it? Okay, and Faraday will be simply answered this question with quietly. What was the use of newborn baby? Okay, we will soon see the greatness of the little child who has now grown. So one child does not give any, without the use of any one child, because the child will be grown. Okay, some characters also it will be built up with the child, and as well as one concept it will be given, that the concept will be developed in various ways, that the concept will be used in various ways, that it will be applicable in various ways. That's the concept it will be given by the Faraday in one conference. Okay, so in the today topic, so definition of electromagnetic induction, magnetic flux, and Faraday's first experiment, Faraday's second experiment, and Faraday's first law and Faraday's second law. What is the use of electromagnetic induction, and then one activity for electromagnetic induction. Okay, home assignment for today's session. Short answers 1, 2 and detail 1 in unit 4. Okay, learn and write the short answers 1, 2 and first detail in unit 4. Okay, short answer 1, 2 and detail 1 in unit 4. Okay, thank you.